and I'll arbitrarily put some, let's say the base liquid is water here, up to a certain height. And I could arbitrarily put different liquids on different, in the different tubes. Last time, remember, we had the oil on one side and then we just had water on the other. So what if we added here oil, 12 centimeters of oil, and the density is 0.91. 0.91 gram per cubic centimeter. That's what we used last time. Let's say we put here, this one, we put alcohol, okay? And let's say the alcohol is 0.81, the density. 0.81 gram per cubic centimeter. Of course, it depends on what kind of alcohol and stuff, but the alcohol tends to be a little less dense than oil. And then let's say on the right side we put mercury. So this one, let's say, is 15 centimeters high alcohol. Okay. 15 centimeters high. And then let's say this one, we put just a tad bit of mercury. So let's say we put 2 centimeters of mercury. And I'm going to assume here that mercury, I'm going to put mercury, but it's not going to seep into the water. Okay, but in reality, if you try this, it might actually seep in and start to go down. But I'm assuming here, let's say the water's surface tension prevents the mercury from actually seeping down. And the mercury is actually very dense and compact with a liquid, so it might actually just stay there. So let's say the mercury has a 2 centimeters there. And on top of the mercury, I could put some more oil. Let's say 8 centimeter of oil. Density 0.91 gram per cubic centimeter. And then the mercury's density is gonna be 13, I believe it's 13.6 gram per cubic centimeter. So now what's gonna happen? How will these liquids reposition themselves? So of course the mercury is gonna push everybody down. It's going to want to go down, everything is going to go back, everything is going to go up. So I want to know at the end, what are the new heights from, as measured from the top. I'm not going to be worried about the height from the bottom of the bottle. So the bottle could be as deep as it wants. And I'm not going to be worried about the height from the bottom. All I'm going to ask is, how do these reposition themselves, and what are the new heights from the top of each one? Okay. Well, we could probably all agree the mercury is going to go the most down, the oil is going to go down with it. And then out of these two, I have alcohol less dense, but I have more height. So I'm not sure exactly which of these will go up higher, because this is more dense, but there is less of it. So one of them might go higher than the other one. So at the end, it's going to look something like this. So the mercury is going to be way down. So imagine like this here. So imagine this is the mercury. Imagine this is the oil. And then the alcohol, let's say, is way, the water. This is the water here, the water level. So this is water. This is water. This is alcohol. This is 15 centimeter. This is 8 centimeter. and this is 2 centimeter. Okay, and this water, I'm not exactly sure if it's going to be higher or not. So let's just say for now, let's say it is higher. So let's say it is something like that, W, and then there's 12 centimeter of oil. So oil, 12 centimeter. So that's kind of like the, now I want to know what is the difference of the heights here. Okay, so let's do the equations and stuff. So the way that we approach that is that we say the water, this is the highest point of the water for the right side of the tube. At the same height the water here, at the same height the water here should experience the same pressure. Otherwise they would readjust themselves. Okay? So the pressure should be the same. So now we calculate the pressure here. The pressure, and all I really need is the gauge pressure, the difference of the pressure of the atmosphere minus this. So really the delta P. Okay, so that's going to be equal to the density of the oil here. The density of the oil was 0.91, right? So 0.91 times its height, which is 8 centimeter, plus the density of the mercury, which is 13.6, times its height, which was 2 centimeters. So that's going to be the gauge pressure at the water's level over here. That should equal to the gauge pressure. We could call this delta PG. That should equal to the gauge pressure here, okay, which is the alcohol 15 times the density of alcohol, so which is 0.81 times 15 plus some unknown, we'll call this here Y. We'll call that Y. So the distance from here to here at the same level, we'll call that Y. So the density of water, which is 1 times Y. So that we can solve for Y. Set these two equal to each other. So we'll have, let's calculate this here. 0.91 times 8 plus 13.6 times 2 is equal to, this one is 34.48. This one is 0.81 times 15 is 12.15 plus Y. Now notice I ignored the G in here because actually remember pressure is rho G H, but I ignored the G because they both have G. So that is irrelevant here. So now I'm going to set these equal to each other. Set them equal also for Y, and Y is equal to 34.48 minus answer 22.33 centimeters. So this from here to here is 22.33 centimeter. So the difference of the heights of the second tube and the third tube, the difference of this is going to be, well, since Y is 22, the distance from here to here is going to be, so from here to here is going to be 22.33 plus the height of the oil, 15, minus the distance here, okay, which is 10. So plus 15 minus 10, that gives us 27. So in other words, from here to here was 27 centimeters. From here to here was only 10 centimeters. So the difference of the levels of the right and second tube, so that gives us one of the answers here. From here to here is 27.33.